So good evening, and thank you for braving the cold weather this evening. My name is Chris Hyder. I'm Executive Director of the Policy Evaluation and Transformation here at the New York Academy of Sciences. And so again, welcome. So we have an exciting evening for this evening, but first I'd like to tell you a little bit about the Academy, and a little bit about what we're doing in addition to introducing our next speaker. I'd also like to say my colleague Brett Van Landingham couldn't make us, but I'd like to thank Brett and certainly the staff of the Academy and the Nature Conservancy for helping to put on this lovely event tonight. So I've been at the Academy for about 2.5 years now, and the Academy is really an exciting place to be. And for those of you who aren't familiar with the Academy's history, it was started in 1817 as a scientific society and has really had a very integral impact into the cultural and scientific development of not only New York City, but the tri-state area, and increasingly internationally. But I'm not just excited about where the Academy's been. I'm especially excited about where the Academy's going. And so like the topic today, we are seeing the emergence of what many of us call grand challenge issues, right? Transnational, transcultural, transdisciplinary phenomena that are precipitating a change in the way we think, or maybe we should say the way we should think about these emerging trends. And so when you think about areas like climate change, like pandemic diseases and afflictions, systems failure, right? Unintended, catastrophic design flaws, we have to not only rethink our society, we have to rethink our institutions. How science is done, how education is done. And really, that's the role of our group in policy evaluation and transformation. So being the eternal optimist, it's very exciting to be a part of how we rethink science. And more broadly, the Academy is rethinking its own programs and how to best adapt and respond to this changing nature of science. So in the coming months, you'll not only see a continuing emphasis on education and science, but a real focus on impact. And certainly lots of us have talked about impact in education, but we are going to do something about it. You're already seeing this with an emphasis on impact with the recent formation of fairly novel public-private partnerships in the spaces of Alzheimer's research. You've seen it in nutrition. You'll now see it soon in vaccines. And these partnerships are not only multidisciplinary, they're multi-sector. They're involving industry, in addition to universities and the government. And then you're going to see some in the future that deal with science-based entrepreneurship, how we think about our traditional universities and how university education is structured. You're going to see it in the physical sciences. And, relevant to tonight, resiliency in the built environment. So all of these initiatives depend on quality partners, right? Public-private partnerships. And among those, we're very much looking forward to the partnership with Nature Conservancy. A partnership that not only includes the topics tonight, adapting cities to climate change in a post-Sandy world, but also a meeting we're going to have next month about water and where the future of water will come from. And then in March, we have another meeting, the limits of the planet, a debate. So to talk a little bit about not only this partnership, but the Nature Conservancy, I'd like to introduce Bill Ohlfelder. Now, Bill is not only a lifelong conservationist, he just so happens to be the New York director of the Nature Conservancy. Bill holds a dual master's degree from Duke University's Nicholas School of Environment and Resource Economics and Policy, as well as Forest Management. Now, there's a combination. Over the course of his 18-year career at the Conservancy, Bill has directed the Conservancy's Peru, Northern Arizona, Eastern Colorado, and Central Caribbean programs. He helped launch the Conservancy's Mongolia program, focused on the conservation of the largest grasslands in the world. He led completion of the first Debt for Nature swap in collaboration with World Wildlife Fund and Conservation International to provide more than $10 million for national parks conservation in Peru. He launched the largest project in the history of the Caribbean program on free trade and environment, and since becoming the director of the Nature Conservancy in New York, Bill has led the permanent conservation of more than 100,000 acres. So Bill,
great.
welcome. So
Thanks.
Again, thank you and welcome.
Thanks, Chris. That was very, very kind. So the problem with partnerships is it implies multiples. So the Nature Conservancy in partnership with the Academy of Science, I'll just be very brief talking about the Nature Conservancy, because really what we want to hear from our panelists tonight, because these are just great events talking about the issues of our time from people who are very informed, knowledgeable, and engaged. And thank you, as Chris said, thank you all for coming out on a pretty cold evening this evening. So the Nature Conservancy, as many of you know, is one of the world's leading conservation organizations conserving lands and waters on which all life depends, people and nature. Many of you are members, those who aren't. They're Nature Conservancy staff, staffing the desk outside on the way out, or just log on to nature.org and get engaged. We'd love to have you get engaged with the organization. And the partnership with the Academy of Science, one of the things that is a hallmark of the Conservancy is we are a science-based organization. Collaborative, non-confrontational, results-oriented, but science is the underpinning. So these kind of open discussions about what science is telling us about the issues of our time, I think reflect the institutional personality of the Nature Conservancy. So I imagine some more folks will come along. It's a big crowd tonight. But I think part of the reason we have such a big crowd is this is so important. Sandy really changed the conversation. There were models predicting things. We knew much of this, but it took an event like Sandy to change the conversation. And the Nature Conservancy served on Governor Cuomo's New York State 2100 commission about how do we think about the resilience of not just New York City, but all of New York in the face of a climate changing world. And we really saw our role as promoting natural infrastructure, nature, and the role that nature has to play as part of our infrastructure in providing defenses against disasters and other climate effects. And I know that's going to be something we talk about tonight. So we were very proud and honored to serve as part of that commission, but it goes on. Many of you are following in the media, today the governor talking about the buyback program. Many people are living in places where they should not live. What do we do about that? How do we manage those programs? So it's great to see you all here because it's such an important topic. Clearly you want to get engaged, learn more, and make a difference. So with that, I will turn it over to Andy Revkin to introduce our panelists tonight, and thank you all on behalf of the Nature Conservancy.
Great. Hopefully my microphone, yep, I think it's working. It's great to have you all here. This should be a dynamic and productive conversation. We have everything from basic climate science to urban planning expertise represented on the panel. We're going to start with some basic climate science and then move forward through what's known about the exposure to hazard and how that's changed in recent decades. We've built a huge amount of stuff in harm's way. We're living in a 19th century city with a little 21st century veneer on it. And you'll hear a lot about that from the esteemed author next to me. But first we're going to start with the climate picture. At the far end here, there's been some changes in the lineup just due to some of the kinds of chaos theory things that happen to everybody. And Radley Horton, it's a great pleasure to have Radley come in and substitute a little bit for Bill Selecki. Now Radley is a climate scientist, and I'll let him kind of explain a little bit more about his background. He's at Columbia University, and we were just talking about a course that he runs in sustainable development where students actually get engaged in Rockland County with helping them figure out how to have a more durable outcome the next time there's a storm like Sandy. And at Pace University, where I now teach, along with my blogging at the New York Times, we're developing the same kind of course where there's an active, where students are actually out in the world solving or addressing problems at the same time they're learning. So Radley, could you set the context here for what we had experienced, but in the broader sense of what's coming with climate? Before you start, I want to mention, too, there's a hashtag for your Twitter tweeps, as they're called out there. It's Nature Future. So # Nature Future. If you're on Twitter, I've already posted a couple of relevant pieces that I've written with that hashtag. So get out there. Make sure. What's great about Twitter and the social networks is you can have this conversation transcend the walls, the glass walls of this room. And that's a very powerful thing to do, especially all these issues don't just face New York City. From Kuala Lumpur to, you can just work your way around the world and see the same issues playing out. So back to Radley, give us the basic climate primer here.
Sure. So yeah, I thought I'd do, with the limited time, just, I think the mic's on, yeah. A sort of real quick overview on Sandy, just what was so exceptional about it from a meteorological perspective. Then ask the question of, can we tie this into a change in climate and climate variability? What are some of the potential connection points? And then in the last sort of minute or two, maybe take a step even further back, because the next big event won't be the same as Sandy. It might be somewhere else. It might be a heat wave. What's the sort of big picture context for our changing climate? And I think the one point I'd like to leave everyone with is the idea that we could be on a pathway to changes that are impossible to adapt to. So we have this sort of paradox where we absolutely have to be adapting. There's a huge need, probably more than we could ever do. But simultaneously, I believe we face a real possibility that if we don't change things quickly, we may be heading towards a path that's sort of beyond our limits of adaptation. So first, sort of a quick overview of Sandy. What were some of the things that made it so exceptional? So some may recall hearing that the barometric pressure, this measure of the actual sort of strength and intensity of the storm and its winds, was as high as really had ever been achieved in our historical record anywhere north of about Cape Hatteras. I mean, it was exceptionally strong. There was also the issue of the size of it separately from that. The fact that the storm was so big with tropical storm force winds extending outwards, on the order of close to 1,000 miles, that basically meant that a large part of the North Atlantic Ocean was in motion, was spinning. And that meant that the storm surge was bigger than it otherwise would have been and also affected a much larger area than it otherwise would have. Another component that got a lot of attention was this issue of track. It took a course that, if not unprecedented, is at least very unusual. Normally, when a hurricane gets as far north as, say, Virginia, certainly New Jersey, this late in the season, late October, when you'd normally expect the jet stream blowing from west to east to be strong enough to divert the storms out to the east, that path we usually see. Well, Sandy, of course, took a very different pathway, and that was obviously devastating. And then the fourth issue is sort of just bad luck. It hit right at the high tide, matching the daily high tide cycle. That's a big part of the story. But now stepping back a little bit, and what are some of the interactions with a change in climate? Well, the number one, indisputable, is that we've had about a foot of sea level rise in the New York City area over the past century. Greenhouse gases have been going up, sea levels have been rising. That means that the surge was worse than it otherwise would have been. But in a sense, it was sort of more importantly, I think, more paradoxically, there's this idea that if you sort of raise that floor as sea levels rise, even weaker storms in the future can cause more devastating flooding. Our research suggests, and Klaus will say more about this, that even under conservative sea level rise scenarios, and even if storms don't get any stronger in the future, just by raising that floor, we could have something like 2 or 3 times as frequent coastal flooding events. So that 1 in 10-year event could be something happening once every 2 or 3 years. I think Klaus will go into details about how it could even be worse than that, even if storms themselves don't get any stronger. Another issue, of course, was that we had very warm water in the North Atlantic. All things being equal, that helped that storm stay stronger. That one is tougher to tie to climate change. They were exceptionally warm temperatures, but there is a large role for natural variability in those ocean temperatures. What we can say for sure is that as the planet continues to warm, we expect to see warm ocean temperatures like that more often. All things being equal, that'll add extra fuel to those kinds of storms. And then I'd say the very controversial, even speculative question that a lot of people are now asking is about that track, that issue of track, the fact that it took that turn back towards the west, which is so unusual. That happened essentially because the pattern of the jet stream. As I said, the jet stream normally, not always, but normally by late October has a strong west to east orientation. And we didn't see that at all. Some people probably remember seeing those maps where there's a sort of kink that enabled the storm to make its way back towards the west. But what does that have to do with climate change? We don't know for sure. What we do know is that there's been a huge loss of sea ice in the Arctic. The volume of sea ice in the Arctic in early fall has dropped by something like 70–75% in the last 3 decades. This is way outside of the patterns of natural variability. Now, it's speculative to try to link that to the jet stream. But there is early research suggesting that in the last several years we're seeing more of that type of wavy pattern. There's also some foundation in thinking that as those polar regions warm a lot in the fall, sea ice used to be there as the sun would set and fall, temperatures would drop fast. The Arctic ice cap was essentially a continent. Once the sun went down in September, October, temperatures would plummet. With that open water, more and more, temperatures are staying 32 degrees or so into September, October. You're losing what used to be a really strong temperature gradient. It's weakening between the equator and the pole. As a result, there's less powerful forces pushing things west to east. It's not a home run. More research is needed, but it's an important area of research. I'm probably coming up towards the end of my time. But to step back sort of one step further, I've talked about sea level rise. Obviously, there are a lot of other issues. As I say, the next storm isn't going to be the same. We need to be thinking about extreme temperature events, intense precipitation events, and a range of other factors. We're about to see the next IPCC report come out. It's going to be based on a new set of global climate models that have improved in many different ways. There will be some differences in those model results, but I think in a lot of cases it's going to be a very similar story, things that we already knew. Temperatures projected to increase a lot, sea level projected to increase a lot. Some of the confidence will be higher, but in a lot of ways we sort of already know what these dangers are. And we already know about our vulnerabilities. You know, Klaus has been involved in reports that pointed towards the vulnerability as we build up along our coasts. But even though we've sort of known these model results for a while, the point I want to close with is this idea that I believe the evidence is increasing that we could end up in an outcome that falls sort of outside of what the climate models project. And if we look again at this issue of the loss of sea ice in the Arctic, it's happening a lot faster than any climate models have suggested that it might happen. If that pattern continues, it opens up the possibility that the range of outcomes that we might see in the future could also be outside of the range that you'd think if you just looked at climate models. The climate models remain our best tool to predict the future, but I think we need to be open to the possibility of surprises and need to think about how we can try to adapt to surprises, but also the idea that if we don't reduce our greenhouse gas emissions, we may be heading towards some changes that we can adapt to.
That's great. So, and also remember, at about 7:30, we're going to start taking questions. So there are some cards, I believe, on your seats. So keep that in mind and write legibly. That always helps. I've done this before, where sometimes I get Sanskrit and it's hard. Oh yeah, right, like right there or right here. So just try to write legibly. So Klaus, you know, if a hurricane forms and gets really powerful, and then just heads into the North Atlantic to Greenland, it doesn't really. It's a snooze. But when a hazard coincides with a densely populated area, you get a calamity. So you've spent 40 plus years looking at the how we get into harm's way, which is when you have risk, you have hazard and you have population together, and there's a formula for that. And we're essentially highly exposed, not just here, but maybe even more so in many developing countries. So could you take us, and actually Klaus at some point tonight will tell you his own story of exposure to hazard over in Piermont along the Hudson River, where circumstances got very interesting in this recent storm. But first, take us through your basic sense of, you've got the climate basics, and then you've got the development basics at the same time. What's that look like?
With your remark. I had 2 feet of water in my living room during Sandy. So,
but it was partially because he couldn't get permission to raise his house as high as he wanted to, because there's a height restriction. We'll talk about this zoning, conflicting, interests. Anyway.
So I want to really pick up where Radley left off, and particularly focus on sea level rise, because I think it is the greatest threat to the metropolitan area, and of course, globally, to many coastal areas. Think of Bangladesh, think of the Pacific Islands that may entirely disappear. So, sea level rise. Why is it so dangerous for us? It's so dangerous for us in combination with hurricanes or nor'easters. As Radley already said, 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the sea level rise is in the Arctic. 40% of the when you are here, and this is the subway entrance, and you want to flood it where the sea level is down here, you need, in New York City, at least a 100-year storm to flood this subway entrance. Now you raise the sea level rise, and you need only this little storm to flood that subway entrance. So you can do it with a much smaller storm, but smaller storms are very much more frequent. That means your probability in any given year that something bad happens increases. And when we take a particular sea level rise scenario, the New York panel on climate change put out called the so-called rapid ice melt scenario, or RIMS, then you will find, when you crunch the numbers, that in the 2080s, the chance that in any given year, that 100-year storm, which floods subway levels now, will occur every 2 years. That's a 50-fold increase in the probability. Now, to run a global financial city with that risk is unthinkable. That's my first point. The second point is we have to adapt to it. And there are generic ways to adapt. One is protection, fighting Mother Nature, even so it's humanly manipulated nature through the human component of climate change, but it's still nature. The second is accommodation. So that means you clean out your lower basements, and if it's a skyscraper, you make that into a garage. You put all your essential facilities on the top, and you let the water come before you, of course, put the cars out of the garage. Or like I did and will do again, raise your house, if it's an individual house that is raisable. That would be accommodation. And the last point is managed retreat. And we will have others focusing on that. But I think that needs to be much more aired in the public, because it's obviously the hardest to do. It means communities will not be where they are now. I spent on 2 weekends now with communities out in the Rockaways. Nobody wants to talk about moving. Everybody wants to see how we can improve it. I think New York City will have a slightly smaller footprint. We will have to change our density pattern accordingly. We will have more parks on the waterfront as buffers. And we have to change our infrastructure radically, not just the subway. Think of all the wastewater treatment plants on the waterfront. These will be huge investments in the tens of billions of dollars. The good news is that on average, for every $1 that you spend to mitigate that infrastructure, to make it resilient, you get about, on average, $4 back in not incurred future losses. That's a 4-to-1 benefit ratio. That can vary, but just to give you, I mean, if I would know I could buy a Wall Street paper with a 4-to-1 return, I would buy it today. The human nature, however, is such that we not play the lottery on not losing. We usually play the lottery only on winning. And that is a misconception, because not losing is winning. And we have to learn that. I want to throw out one thing, because it's so wonderfully controversial and everybody gets very excited about it. That's we should have storm surge barriers and we don't have to do anything. Here's the bad news. Now let me first say the good news. The good news is that they are good for keeping storms out. But what they are not good for is to keeping sea level rise out. Why? Because normally you want to have the barriers open so the ships can go in and out and the fish can go in and out and the Hudson River can go out in the ocean, the Passaic River and the Raritan River and the Hackensack River. Well, as sea level rises and it comes to the point that it reaches what we now would call a 100-year storm height, roughly sort of around the end of the century, depending on the sea level rise, maybe a little bit later, maybe even a little bit earlier if those bad forecasts come to fruition. If you open those gates, and you better do it because otherwise you flood from behind when the Hudson can't get out, the ocean will get in. They want to equalize. So you still can, storms keep out there, but you can't keep the ocean out. And that means, and this is my last point, that managed retreat is a necessity sooner or later. And if we build barrier, we think we are safe behind those barriers for longer than is good for making the change to managed retreat happening now. Meaning not now and next year, but starting it now and spreading this process out over 100 years rather than procrastinating 100 years and then suddenly being faced with it like a la Katrina in New Orleans. That's it.
I'm taking notes furiously here. I hope people are tweeting because there's some really important concepts here. And one thing that, there was a recent World Bank analysis. There's an economist named Stefan Halgate, who I wrote about during Sandy, who did an analysis of how, just exactly what you talked about, where we get comfortable with interim measures and we kind of avoid the big knock. And we feel like it actually pays to be in harm's way most of the time, economically. It pays to have your city on the coast. But what you do when you sort of have an incremental approach to that, you end up actually ending up with a mega loss at the end. You're sort of resisting the exposure, getting little things done, and then kaboom, you could really get what he said. We're entering an era where we're going to see mega losses as a result. And the same thing, Klaus has done work on earthquake risk as well, and you see the same kind of patterns there. So, but you did mention, both of you mentioned this sort of soft and hard approach. One of the most interesting aspects of the Cuomo New York State 2100 report to me was that they talked about the reality of this suite of options, that some of which are hard and some of which are soft. The idea of a managed retreat, of more natural barriers becoming a real good investment, dunes and wetlands and oyster reefs, as I wrote about, the kids at New York Harbor School, who I sat on a panel here with a year or so ago. They're actually cited in that Cuomo report after I wrote about them, which is kind of great. So that's a good segue to Nicole Marr, who is the senior coastal scientist for the Nature Conservancy. And so tell us about the soft side, the green infrastructure, and how that could realistically play a role in fostering some resilience in a situation like this.
Thank you, Andy. So tonight I do want to talk about how green or natural infrastructure along the coast and the role that it can play to help make us more resilient in the face of climate change and coastal storms. And New York City, I've got a slide. Oh, there it is. Great, thank you. New York City was settled in where we are in part because of its rich natural resources. Historically, we had very extensive wetlands and oyster reefs along our shores, but since the early 1900s, we've lost more than 80% of our wetlands and virtually all of our natural oyster reefs. The first map that you can see shows the historic distribution of wetlands in New York City in very, very faint green, and the dark green shows the wetland extents that remain today. The problem with losing these natural resources is that as we lose these acreages, we lose the critical services that these natural habitats provide for us, both during the time of storms, but also during all of the quiet times between storms. We really rely on these natural resources to support, so in ways that we too frequently underappreciate. They support a healthy coastal ecosystem and all of the cultural and economic activities that are contingent upon that. One other factor that makes parts of New York City especially vulnerable to sea level rise and coastal storms is that in addition to building out to our natural shorelines, here in New York City we even built beyond our natural shorelines. And what you can see in the second sort of map is sort of a rendition. The area in the center, this is southern Manhattan, is what Henry Hudson is likely to have encountered when he sailed into this area in 1609. But since that time, as we built our city, we've expanded even beyond the natural shorelines of Manhattan, making us more vulnerable to these coastal storms. But what Superstorm Sandy has done for us, it has given us, so brought our vulnerability to the forefront. And it has presented us with the opportunity to rethink our coastal practices and to make smarter decisions. And so by being proactive and addressing these issues now, we have the opportunity to build a more resilient city that is healthier both for people and nature. So in response to Hurricane Sandy, as Bill had mentioned earlier, Governor Cuomo formed the 2100 Commission with the task of assembling a set of recommendations for how to make New York State's infrastructure both stronger and more resilient. And one of the very important recommendations from that commission was that New York should promote the use of natural or green infrastructure as part of a solution for making our city, our state more resilient. And a green infrastructure approach relies on natural habitats, such as wetlands and forests and floodplains, to provide that risk reduction to protect our coastal communities from the brunt of these storms. Green infrastructure would also include restoration projects along the shorelines or living shoreline projects that complement traditional infrastructure. So these natural habitats along our shores do provide some physical protection from the brunt of storms. Wetlands, for example, do slow the velocity of waves along the coast, reduce erosion along the coast, and grow when the wetlands are healthy in response to sea level rise and increasing in elevation. But these systems also provide additional benefits that no built infrastructure does, traditional built infrastructure. They also, wetlands, for example, purify our coastal waters by removing contaminants. They fuel our coastal food webs. They sequester carbon to mitigate the effects of climate change. They support a diverse habitat for wildlife. They support sort of our coastal character and drive our vibrant coastal economies. So environmental benefits, societal benefits, and economic benefits. The Commission also acknowledged that these natural habitats, which are crucial to maintaining the economy and resilience of New York, are themselves vulnerable. So if we want to rely on this natural infrastructure to make us more resilient in the face of climate change and storms, we need to address the threats to those systems. Coastal development is a big threat, but water quality is also a really big threat. So if we want to rely on our salt marshes, our wetlands, our shellfish beds, our seagrass meadows to continue in a self-sustaining manner, we need to address these threats. So all this said, so if natural infrastructure along the coast is not going to stop a 17-foot storm surge. And certainly sort of all natural or built infrastructure all has its limitations. So what we need to do is to evaluate the capabilities and the limitations of both green and gray infrastructure. But I think in summary, these natural systems can provide part of the solution, because not only do they provide us some protection some risk reduction from these coastal hazards, but they provide these other benefits. So it's a win-win situation. I think I'll just allude to the picture on the bottom right here was taken at about 12 noon in Milford, Connecticut, so along during Hurricane Sandy. And what you can see is sort of that natural shoreline there is, you can see the dramatic, sort of the difference in wave energy between the outside and the backside of that.
That's great. Something you mentioned reminded me, in 1992, I wrote my first book on global warming. And it's, I posted the text online recently. It's 20 years now, and 20 years last year. And there's a great section, I think, that resonates with what you just described. And actually, it's relevant to what James is going to talk about. In 1875, there was a book written by Senio Scott called Fishing in American Waters. This is just to give you a sense of the transition in our landscapes. And he said, there's not within any settled portion of the United States another piece of territory where the trout streams are so numerous and productive. It is scarcely possible to travel a mile in any direction without crossing a trout stream. Where do you think he was talking about? Long Island. So, boy, have things changed. So one of the questions that will be resonating here is, can we peel back? What combination of politics or education or whatever can foster a willingness to sort of give nature some more room? Because all of these steps are going to require space. How do you value that? How do you convince a town board or a zoning commission that there's economic value there? These are real big challenges. So we're going to move to Rob McDonald, who's your focus is urban land use, sustainable urban land use, which gets at this very question. So not just in the marshes and wetlands, what can we do to build cities that, and actually, if you can take us in a global tour at all, that are more resilient in the face of what's coming, that would be great.
Yeah, no, so my job in this panel is to sort of pull us back out, and he'll do this as well. So to me, I want to take a little bit of exception to what I heard down in this end. To me, the lesson of Sandy is that American cities are right now not adapted to this climate, right? Let alone future climate. So it is certainly true that we live in a world of climate change, right? So the ocean's warmer, that made Sandy a little worse. Sea level's a little higher, that made it worse. But we also had a city, a major American financial city, that wasn't resilient to something like the 1938 hurricane. So this is not an unprecedented event historically, and neither was Katrina, really. So to me, that's the scandalous thing, is that as a society, we are living with very high risks in our cities. And so to me, the lesson is you start with adaptation now, right? And you're heading towards being resilient to this current climate and towards the future climate where the hazards may be even bigger for all the reasons that were talked about. I think the note of optimism, to give it the global perspective Andy was talking about, is that the US has resources to do this. Europe has resources to do this. If we want to make our cities adapt to climate change, it'll be very expensive perhaps, but we can find a way to do that. I spend a lot more time worrying about cities in the third world. Somebody mentioned Bangladesh and Dhaka, for example, huge coastal flooding issues with maybe a 50th of the financial resources that New York City could marshal. So that's a big global equity issue, right? The US and Europe put out most of the emissions, and a lot of the deaths that may happen because of climate change will happen in cities in the third world. I want to make kind of 2 points just to put them in the mix. First is, some general once said, and I tried to find the source of this quote and I couldn't, don't fight the last war, or don't just fight the last war. So there's this natural human tendency after a tragedy like Sandy to focus in on how do we protect our shoreline, and that's going to be super important. You can see from the makeup of the panel, that's what we'll spend most of tonight talking about. But other things are going to matter, and if you talk to folks at World Health Organization, they'll say coastal flooding is probably number one. Actually, heat waves is arguably number two. So people forget about this, especially when it's freezing outside. It's hard to talk about heat waves. But I was researching heat waves for a book chapter I'm trying to write, and talked to the reporter at the time in Paris, France. So in 2003, when the really big European heat wave hit. And I asked him, and this sounds crass, but I was looking for a good quote. So I was like, so what do you remember about that summer? And he said, I guess what I remember is the bodies stacked up in vegetable coolers. And he meant that. I mean, in that summer, 70,000 people died in Europe. And they were mostly elderly, and they died alone in apartments, but it was a really significant event for Europe. And the solution was not rocket science, right? So it's having a system for doctors to reach out to elderly people who don't have someone to care for them, having a space where there's fans or air conditioning, and having more street trees, actually. So there's a nature side to this as well. In French neighborhoods, there's actually really good data on this. Neighborhoods that had more trees had less death because it just got less hot. So to me, the good side of that Europe story is that several years later, there was another heat wave in France, and their mortality rate went down a lot. So in a couple of years, France learned from that mistake. And cities that have planned well, like Chicago in the US, have done better in heat waves than they did in the 90s. So heat waves are a solvable problem. It just takes resources and planning. Disease is often third on that list, and it's something that it's easy to think about that as, oh, it's a developing country thing, right? Malaria is going to be worse because the mosquitoes that are its vectors may spread or get more abundant. And probably in terms of human impact, malaria is the biggest disease impact. But even in the US, we feel this, right? So in 2011, there was a very big outbreak of West Nile virus in Texas. More than 40 people died. That outbreak was clearly worse because the temperature was very high, and I think there's good data, in many ways better data than for the coastal storm stuff, good data that those kind of extreme summer temperatures are climate change related, and we'll see more of them. So even in a place like the US, we're going to have to think about how you deal with West Nile virus, for example. So that's kind of point two. Don't just fight the last war. A smart city is going to have to think about all those dimensions. I think the third point is, and this will lead in, I think, to our discussion of urban planning, what future climate are we planning for? Right? There's a choice humanity has to make of how much we want to keep putting out greenhouse gases and how hot it's going to get and how bad climate change will be. And so if we spend more on mitigating and reducing those emissions, climate change will be less severe, and we might have to spend less on adaptation. And to build off something that someone said, if adapting is cheaper than reconstruction, I'm pretty sure mitigation is a lot cheaper than adapting. And so we have to keep pressing that point to policymakers. The other thing I want to interject here is just a note of caution. I really agreed with Klaus's point on this. I think it's Klaus. There's just a lot of uncertainty. The things that worry me most are the uncertainty. So we're doing this giant unreplicated experiment with the globe, and yes, there's lots of fancy models, and I spent part of my life using output from GCMs that these guys run to think about hydrologic flows, but there will be huge surprises and things that cities have to adapt to that we can't predict on the stage tonight. So how do you do urban planning in that context where you don't know how bad climate change is going to be, how bad sea level rise is going to be, and there's going to be sort of the unknown unknowns that planners have to deal with too. That's, I think, the challenge we should talk about tonight.
Absolutely, and which gets it perfectly to James Russell, because the title of his book on this issue is Agile City. In other words, agility to me is a vital term to apply in a situation where you have implicit uncertainty, where you can have unforeseen consequences. I'll give you one example. In the late 90s, when I was writing for the Metro section of the paper, the Times, I covered a really big winter flood where there was a lot of snow accumulation and then a heavy warm rain in January. And the reservoirs got very turbid. And when you look at climate forecasts, you know that heavy downpours are pretty confidently forecast in a warming world. So turbidity in the reservoirs is not an issue that is not right on the top of your list. But if you got to deliver 1 billion gallons of water a day to an urban area of 8 million people, and suddenly your reservoirs are getting more and more turbid because of runoff, then you have a whole nother issue. It's like someone snuck around the back and invaded from another direction. And water is, as you'll hear in that panel here in a couple of months, water is a vital cornerstone of human enterprise.